Okay, so yeah, this question's from last year's exam, and it's an early question, so it's sort of one of the easier ones, and I think it's a good one for us to go over together, just to recap some of the basic skills that we've talked about with complex numbers, leading up to our test on Thursday. So I'd love to spend a bit of time with each of you guys and just find out what it is you're wrestling with, and how you're going in preparation for the test. So for this question, we're asked to write the following complex numbers in exact polar form. So the first thing we're just going to do is use our calculator. So for A part 1, we've got Z1 is root 3 take 3i, and we're just going to convert that to polar form just using our calculator. And I did this earlier this morning. Root 3 take 3i, we've got 2 root 3 cis of minus I. Alright, so make sure you remember how to do that in your calculator. And then Z2 is 3 root 3 take 3i. It goes to 6 cis of minus I. Alright, now we've said the complex numbers Z1 and Z2 from part A are shown on the Argand diagram in figure 2 below. The measure of the acute angle between Z1 and Z2 is theta, okay, as illustrated there. Part 1, write Z2 divided by Z1 in polar form. Okay, so Z2 divided by Z1, that's going to be 6 cis of minus pi on, Z2, minus pi on 6, divided by 2 root 3 cis of minus pi on 3. Now we'll be using one of the properties of polar form here, which is if you have cis of theta on the cis of pi, it's equal to cis of theta take 5. Alright, now the numbers we can just divide. We have 6 divided by 2. Now in my mind, like you can just type that in your calculator or punch it out in simplest form, but I'll just break it down. 6 divided by 2, that would equal 3, so you can have 3 on top of root 3. And 3 on top of root 3 is the same as root 3 times root 3 on top of root 3. Alright, 3 can be represented as root 3 times root 3. Root 3 at the top and bottom can cancel, and so 6 on 2 root 3 will just simplify to 1 log root 3. So our answer will be root 3 cis of, and then we have the first angle take away the second angle. So we're going to have minus pi on 6 take away negative pi on 3. That makes it minus pi on 6 plus pi on 3. That makes it pi on 6. Okay, and again, all of that we can process that in our calculator. We can process this angle subtraction in our calculator. It will simplify it for us. All right, and then part 2, state the exact value of theta. So on the Argand plane, we have these two complex numbers. We have Z2. No, that has an angle of pi on 6, and then we have Z1. It's not large. I'll scale it back a bit. Z1, and we know that that has an angle of pi on 3. So then we're asked, well, what's the distance, what's the argument between those two complex numbers? Well, it's just going to be the big argument take away the small argument. If I go pi on 3, take away pi on 6, that gives us the value of theta is pi on 6. Now, it's important here, it's not asking for direction, it's just asking for magnitude. What's the size of angle theta? Determine the value of theta. Theta is a magnitude of an argument, doesn't have direction, and so we're just going to list it as pi on 6. Okay. The complex number Z2 is scaled by a factor of half and rotated anti-clockwise around the origin through 3 theta on 2 to produce complex number Z3, as shown in figure 3. Right, let's scroll down. Okay, here's Z3. So it's multiplied Z2 by half, so it's half the length, and then it's rotated at 3 theta on 2 units around the Argand plane. So what that means is Z3, I'm going to write it out like this. Z3 is equal firstly to half of Z2. And then because we're rotating it 3 theta on 2, we're multiplying it by cis of 3 theta on 2. Okay? All that's going to do is shift it 3 theta on 2 units anti-clockwise. Now, theta is, what did we discover? Pi on 6. So all we're doing then is we're just going to evaluate this here. So we've got half. Z2 is this complex number here. 6 cis of minus pi on 6 times cis of 3, I'm going to write it like this. It's 3 on 2 times theta, and the value of theta is pi on 6. Okay, so then we've got these numbers out the front. Half of 6 is 3. And we're going to use the other property of polar form, which is when we have cis of theta times cis of phi, it's equal to cis of theta plus phi. Alright, so we're going to have cis of minus pi on 6 plus this one here, which will be 3 pi on 12. And that gives us 3 cis of positive pi on 12. Alright, so pretty happy with remembering those properties of polar form, remembering the Argand plane. Any questions about that one in particular? Alright, so I do have some other harder ones that I would like to go over at some stage, but I think probably the first priority might be to come around and see how you guys are doing, answer questions you've got, see if there's some stuff in common we should go over before we start to look at some of the more challenging ones. Alright, cool. Stop there.